A common way in which people approach the parallelization of a code is to run something called a profiler to see in what section of the code one spends the most time, what section is the most compute intensive, and to then focus on parallelizing that particular section. Now, if you're not careful, you can paint yourself into a corner with this. Let's analyze this. What if we have a program that requires t time to complete? And what if the fraction of the time that you decide not to parallelize is f? Let's analyze this. Well, the total time can be written as 1 minus f times t plus f times t. Okay? This is the part of the time that you decided not to parallelize. This is the part of the time that you're focusing on parallelizing. Now, if you parallelize this part perfectly, then you would cut that time by a factor t. Well, if we don't allow superlinear speedup. Okay, but that's very optimistic. So really, we expect our parallel time, which we denoted by t sub t, to be greater than or equal this. And even if we parallelize this perfectly and use an enormous number of threads, the best we can then hope for is that this entire part of the time goes away altogether. So we know that this is greater than or equal to f times t. Now, what do we know then about speedup? Well, speedup we defined as the time it takes on one core, sequential time, divided by the time it takes on t threads on t cores. Okay, well, because t sub t is greater than or equal to that, we then conclude that the best speedup we can expect is t divided by f times t. That puts a bound on the speedup that we can attain. We then cancel the t's, and we find that the speedup is at best 1 over f. All right? That's known as Ahmdahl's law. Now let's look at an example. What if you decide that 20% of your code is not worth parallelizing? The part of the code where you spend 20% of your time. Then what this here says is that the speedup is then bounded by 1 over 1/5, 20%. And therefore the best speedup you can hope for is a speedup of 5. Now, that's a little demoralizing, isn't it? It means that you really have to work hard on parallelizing every part if you want to be able to use a large number of threads. Well, it turns out that in our situation, things are a little bit rosier.